So ocean beyond Earth. Why are we finding oceans beyond Earth? We know that on Earth, ocean is almost 70. It resides almost 71 percentage of the Earth's surface. Remaining 29 only there is land. So we know that ocean is something which is most common on the Earth's surface. That's why we call it blue Earth or blue spot. Why, on Earth, when was the first life form started, and where was the first life form started? Or it was a unicellular organism, which means that only one cell was there. So where was the first life began? Can you say that?
In
Nobody
water.
knows? Yes, in water. It says that it was, billions of years ago. mm, the first life was formed in ocean. And from ocean only all the life forms evolved into what we see around in the world now. That is a diverse amount of species. Lots of things are there, right? Like if we just look around the world, we can see plants and animals. We can broadly divide all the living things into plants and animals, different kinds of plants, different kinds of animals. It says that the first life ever produced on earth was from the ocean. So that's why we are really keen to find where is this ocean beyond earth. If there is an ocean, or at least water, that when Chandrayaan was found, some amount of water in the poles of moon, it was quite a big discovery, right? We are still trying to find water or signature of water on the surface of Mars. So why we are so specific about finding water outside space? Because in outside, wherever we find water, there is a good chance that there can be life. So that's why we find, or we try to find oceans beyond Earth. And these NASA people, along with oceanographers, really seek these idea, or any kind of information regarding the presence of water on the outer space. So here you can see an image. Can anyone recognize this celestial body?
Ma'am, maybe it is Mars.
No, no. Mars is red in color, right? No
No.
white is there.
Neptune.
Not Neptune. This sometimes somewhat looks like some rocky kind of thing or solid kind of thing. Neptune is a gaseous planet.
Is this
Mm.
moon?
Huh?
The moon.
Moon,
Ju-
not Jupiter. I'll give you a clue. It's not a planet. It's a satellite. And the white color you see is ice. Okay, after the end of the session, you will be able to recognize the celestial body. Don't worry.
Pluto.
Not Pluto. Don't worry. We will study about this particular celestial body. So, if we find, when we find, or when we ask what is the origin of water itself, then we want to start from the origin of the universe itself. Hmm? When was the universe got birth? When was its origin? Please tell me. We studied cosmology. We are students of cosmology now. Now, if someone asks, what's the age of universe, you should jump and
14
say
billion years.
that is 14 billion years or 13.8 billion years. Okay. So before that, we know that the whole everything that we see around the universe, All the masses, everything, the dark energy, the dark mass, everything was confined in a singularity. So, what happened to that singularity, we don't know. That is, we don't know why Big Bang happened, but some kind of, what to say, mm, unbalanced force or something happened to that singularity, and it started to expand. It slowly got expanded. Okay, and when the first microseconds, few seconds, was really crucial for the universe. You can see a time scale in the x-axis here. So when the time was only 10 raised to minus 35 seconds, that is, you know, 10 raised to 35 part of a second. That is very, very, very small amount of time. Very, very less compared to a second. So in that times itself, you know that there were certain particles there. You remember we studied about quarks in the particle.
Yes, ma'am.
Yeah, it is
Yes.
with quarks this neutrons and protons are made. Okay, I hope you remember that. So these quarks were formed during this period, and after then proton formed. How? The quarks joined together to form protons, and then neutrons were there. And that time also an atom was not present. So later, you know, these protons, we know what is proton. What is the atomic number of hydrogen? Anybody? How many protons does a hydrogen atom has? Any idea? Don't worry. It's just one proton. Okay. So there was one proton. That hydrogen atom was there. And later with this water, the water is made of hydrogen and oxygen. So hydrogen was there. And after this, from where all other elements were formed, from where the supernova explosion, right? Hmm? So it was from the supernova explosions these elements were formed. Okay.
Okay, ma'am.
Yes, ma'am.
So you know what a supernova explosion is there. We have studied the stellar evolution classes. Even though we have already studied it, I'll just, very, very shortly explain it in any case if somebody has forgotten it or just for reminder. I know that all the stars take birth in a nebula. Nebula is called the Cradle of Stars. You remember that? The Cradle of Stars. It's from where the stars form. What is there in nebula? Mostly hydrogen and some helium is there, right? There are also some trace elements of higher elements. So anyway, when a star is formed, when what to say, protostar has sufficient amount of mass, it will become a star. So when we call a protostar star, when we call it when the inward gravitational force is balanced by the outward radiational force. You remember all those?
Yes, ma'am.
Yes, ma'am.
Yeah, I hope you remember that. Some stars are less massive, but some stars are very high massive. So, these elements, higher order elements like, up to iron, all the elements up to iron is made from a supernova explosion. We have already studied that. And what happens after supernova explosion? Let me see who remember that.
Black hole.
Or straightly from supernova to black hole.
Neutron star.
Very good.
Ma'am, it is maybe black hole or supermassive black hole.
Supermassive black hole from star. Supermassive black holes are not formed as an evolutionary stage of star. It's some other process which is responsible for the formation of supermassive black hole that we don't know. But the other thing, what the stellar black holes, the comparatively smaller ones, they are actually uh, formed as a last stage of stellar evolution. Soon after the supernova explosion, what is this remnant called? Hmm? Remaining the core of the star will be there, right? What is it called? The neutron star. So, what is the condition for forming a black hole from a neutron star? Hmm? What is the condition of forming a black hole from a neutron star? Can you please, anybody, please tell me? Hmm? You forgot that. Oh no.
Ma'am, please repeat the question.
So the question is, if you have got a neutron star, what is the condition of this neutron star to become a black hole?
It merges with the companion star.
No. You have got a neutron star, just one neutron star. So is there any chance that this neutron star can become a black hole? Yes or
It is
no?
more than 3 solar mass,
Very
it
good,
becomes
very
black
good.
hole.
Yes, very good. So if the mass of neutron star is greater than 3 solar masses, then of course no force in the universe can help it from colliding into itself and it will become a black hole. Okay, that's how a black hole is formed. But what if the mass of the neutron star is less than that of 3 solar masses?
It
It will
remains a
stay,
neutron star.
yeah, it will stay as a neutron star. Okay. So anyway, my point was all these elements are created from supernova. Everything that you see in your home now, like you can see carbon, a lot of you can see wood there, it's carbon. Then you're using a plastic, right? And you're using your laptop parts, everything is actually a remnant of a star. We ourselves, the carbon, the our body and the elements which is made to create or merged or in a particular way to create us is also from a star. We all are stars or parts of stars. But the cells on your left hand can be from one star, and the from right hand can be from some other star which is millions of light years away. So lot of a lot of stars, supernova explosion was needed to make anything that we see on earth. Not the higher order elements, I'm saying about elements up to iron. Okay. Okay. So how did this water formed? So you can see an animation here. One red big ball and then two small, one big ball and two small balls. Okay. And the big ball, the red one, is trying hard to keep these two little balls. You know what are these balls? Any idea? It is a water molecule. The red one is oxygen, while the white two little ones, it's laughing and it is so mischievous and it's going away.
Hydrogen.
Yeah, they are hydrogen. So this is how a water molecule looks like, right? It's an animation, of course. Uh, Oxygen with two hydrogen atoms. So what are the conditions of formation of water in the early universe? Hmm? How does water formed in the early universe? Let's see. There are three basic things needed to, prepare water in the early universe. What are they? Am I really audible? Is there any problem with my voice? Please tell me, okay?
You're audible, ma'am.
So then, three things are needed for the preparation of water, the formation of water. What are they? The dense gas, warm gas temperatures, and the presence of oxygen. These are the three things essential for the formation of water in the early universe. Okay, so what is this dense gas playing a role here? So if there is a dense gas, particle collision, if things are denser, which means that things are pressurized, so particles will collide each other frequently. Hmm? And what happens then? There is a good chance of formation. If hydrogen atoms are there, then oxygen atoms are there. So there is a good chance that the hydrogen and oxygen, meet each other, collide each other, and there is a good chance that water can be formed. And also, since there is a presence of thick gas, so if there is presence of thick gas, what will happen? It can help the water molecule which is formed inside this dense gas, hmm, from ultraviolet rays. We know that our ozone layer is helping us, preventing us from the harmful effects of UV rays. You know that, right? Our atmosphere is playing a big role, a great role in making everyone on Earth, any living organisms on Earth, alive by protecting us from harmful rays from the sun. Similarly, if there is a thick gas, there is a good possibility that these UV rays cannot penetrate through it. So the water molecules are safe if there is dense gas. Okay. So what is the next essential thing needed for the formation of water in the early universe? Warm gas temperature. So gas temperature need to be larger than 300 Kelvin, that is 100 degrees Celsius. Okay, to start these reactions. So there is a spelling mistake there, I'm sorry. Anyway, start the reaction. For the reaction to get started, the temperature should be really high. So there is a need of warm gas temperature. So the third essential thing is, of course, the presence of oxygen. You know that in the universe, which is the most abundant, if you have one proton, okay, just one proton, which is highly available on the in the universe, hmm, then we can say that okay, it is a hydrogen nucleus. So if it has got one electron to revolve around this one proton, you can call it a hydrogen atom. So a hydrogen atom is a more simple form of element in the universe. So it is highly available. But oxygen is rare compared to the hydrogen. So it is the presence of oxygen which is a limiting factor which limits the formation of water. So the three things are there, then there is a good chance that water formation is happening. Okay. So the story of water on Earth. How can water can come into the scenario of solar system? So for that we will have to study a little bit about the solar system. How did the solar system formed and what made the planets in specific places? and what all things are there in the solar system, etc. During our previous sessions, I think in the first module, and I think in the yeah, in the first module, the planetary, we studied about different planets, the sun, etc., right? in that in that module, we studied about the origin of universe. I hope you remember that. I'll tell you, very briefly regarding the story of sun and the planets around it. It was like 5 billion years ago. There was a nebula called a planetary nebula called a solar nebula, and inside this nebula there was something forming, that was our sun. So sun was formed, when sun was first formed, when the first fusion was occurring in the core of the sun, and it was emitting lots and lots of radiation outwards. That time, like any star, it the sun also covered, or jumped a particular fact called, that's Jean's mass, right? When it when it got the Jean's mass, and when it was slowly becoming a perfect star, a main sequence star, that time the sun was really vigorous. Okay, a lot of solar wind activities was there at that time. A lot of solar wind activities. So it was continuously, spurring away, spreading all, from all 360 directions. This solar waves, mostly with electrons and protons, emitting from all direction on the surface of the sun. It was outward. So you know what happens that time. Any gas, any hydrogen or any such gas was there, it was sent into outer solar system. Only this rocky or solid particles remained. That's why we have called the terrestrial planets, the rocky planets near to sun. But all the hydrogen, helium, all this kind of thing was actually sent backward, that sent away from the sun. Why? Due to the high intense activity of solar wind. Okay, so please imagine at that time sun was really vigorous. It was sending solar wind in all direction. So what happened? Near to the sun, maybe up to the place where now asteroid belt is there. The sun was so vigorous, so what to say, continuously having solar activity, that all the lighter elements with different gases was sent to the outer solar system. Just you just logically think that all the terrestrial planets are near the sun, and all the gaseous planet, and all mostly all the massive planets are outside the uh, terrestrial planet belt. That is solar, after the asteroid belt only all these gaseous planets are there. So this is a reason for that. So even though there was water at that time, the sun solar wind sent all these water molecules away to the outer solar system. And so when Earth was formed some 4.6 billion years ago, by colliding with all these small rocks which was revolving around the sun, when the Earth was formed, it was 4.6 billion years ago. What happened? Hmm? No water was there at that time. So we think that how did this water came into this picture? Water was not there when Earth was formed. So it is thought that water came from some other some outside solar system. It's most probably it's thought that water can be from comets or asteroids or maybe meteoroids. Okay, so there is these two chances. Water can be came from comets. Of course, comets can bring so much of water. Why? Any idea why comets can bring so much of water to Earth? Why we tell that comets have so much of water in it?
Ma'am, because comets are cool.
Comets are
Made
Ma'am,
of
because comets are cool from their inner body, or
why?
from made up of they are made up of ice.
Yes, they are actually called dirty ice balls, right? Dirty ice balls. There are a huge amount of ice on comets. So there is a good possibility that comets can bring water to Earth. But later scientists, when they were studying about this possibility, they cut out this possibility that the presence of water, the kind of water in comets is not the kind of water on Earth. Okay, so there is a good possibility that it's not from the comets. So the second possibility is it's from meteoroids. Of course, ice can be there in meteoroids also. So it can be from meteoroids. So when the Earth was formed, there was no this kind of a strong or a very varied atmosphere was not there. So later only atmosphere formed. So whenever you look at moon, you can see so many craters, right? So many craters. So think about the early solar system. That time the meteoroids number was too high, right? Because it was just forming. Now I think after 5 billion years, it's little bit settled. But in the early times, that is like some billions of years ago, there were many this kind of meteoroids going bound across the universe. It was going from every direction. It was coming from every direction. So if you look at the moon, you can see so many craters. So once if Earth didn't have such an atmosphere, there is a good possibility that that much kind of meteoroids must have fallen on Earth also. So it is said that this it's through meteoroids hmm, that this water came into Earth. So can I tell you something? Have you seen shooting stars? Shooting stars are meteoroids actually. When meteoroids, enter into atmosphere, what will happen? Due to friction,
They
it will
start
shine.
burning.
Yeah, it will start burning. So we can see, a burning ball passing through the atmosphere for maybe a few seconds or maybe for 1 second. It will be like a splash. It will be like a few moment thing. Yes. So it's clear that it was from meteoroid that the Earth got water. But what is the condition of Earth at that time? Hmm? Can you see the video here?
Yes, ma'am.
Yes. So
Yes,
what's the condition of Earth that time? You know what a volcano is, right? You know that from inside the Earth, the magma comes and it will spread, it will just fire. The volcano will fire all this magma outwards. Hmm, and it will, flow in the surface of Earth, like, from the top of the mountain, it will slowly flows. So you know what a volcano is. Similar condition was there on all the surface. Like throughout Earth, this was the condition during the first few times when Earth was formed. Because the temperature was really high that even these rocks were melted. And continuously from inside Earth, this kind of sproutings. We can see some kind of sproutings here, right? See? This kind of sproutings you can see. So these were,
yes,
yes, so these were formed. This was the condition of Earth those days. So whenever this meteoroids or hit on Earth, still water was there, but it could not form, the water that we see on Earth. Why? Hmm? Because what is the boiling point of water?
100 degree.
100 degree. If the temperature is less than 100 degrees Celsius only, then only this water can be in liquid form. If water
The
is in,
volcano, the heat is too much.
yes, very good. The ball at at this condition the heat is too much. But as time passed by, I mean, a billion year more passed by, and the temperature of Earth slowed down. So what happened at that time? When the temperature of Earth slowed down, and when it slowed down less than 100 degrees Celsius, these water molecules really become like the water, the gas, the steam became water molecules. It got condensed, the steam condensed and became water molecules. And it is said that it rained for hundreds of years, continuous rains for hundreds of years, because that much water molecules, steam was present in the atmosphere at that time. It could not condense because of the high temperature at that time. So slowly this rain was pouring, and for 100 years. So you know that whenever in our city areas or in your region where your house is there, even when 1 hour rain is there, it'll get flooded, right? In my area and all, it's called some kind of there is a pond in our city's name itself. Our district's name is Ernakulam, and this Kulam means pond only. Because whenever this rain is pouring, for say maybe a heavy rain for maybe 15 minutes, then our area will get flooded. So similarly, then what happens after 100 years of rainfall? Of course, a lot of water is there on the surface, and you know that water always flow towards where the height is less. Height of the surface is less due to gravitational effects. You'll always flows down, right? So in that,
So why
lesser
it's
height.
not raining like that now?
Sorry,
So why it's not raining continuously like it used to now?
because there is not enough, water molecules and enough. But that's a very good question, Anjali. But why, now this thing has a cycle now. Okay, when you look at the sky, you can know that whether there is water molecules in the there are clouds in the atmosphere. If you look at your sky and you see dark clouds, you know that okay, water is rainfall is about to come. But all the time, can you see that cloud?
No.
Now, only when that cloud is there, this condensation process will have. There is not only the presence of cloud, but many what is the conditions are there for raining. But at that time, the water which is now in the ocean. hmm, We know the 71 percentage of the surface of Earth is ocean. All these ocean waters was steam, and it was stayed in the atmosphere. So con- the condition is not like that now. Now we have water on the surface, and there is a cycle called water cycle. So due to solar, activity, that is sunlight, it will get evaporated. The water get evaporates, and then it will go once the evaporated water will go up in the atmosphere. When it reaches some trees, the mountains, etc., due to this orographic effect, that's called the effect due to these mountains and all. Then the water molecules condense and it pours. That's how the things work. And the water will reach again back to the ocean, and then this process repeats. But in the early ages of Earth, It was not the condition. All the water we see on ground was in the atmosphere. So much water molecules was in the atmosphere. So it rained for years, centuries. Is it clear now?
Yes, ma'am.
Very good. So that's how this ocean formed on Earth. Okay. Actually, it's about some 3.8 billion years ago this was formed. So now we know that how was water formed. The ocean was formed on Earth, and then we also know that it was from ocean that life got started. You know, there are certain elements or certain molecules needed for the presence of life on Earth. So only since we know that if we find presence of water in some other planets, there is a good possibility that we can find life form in any planet. Okay, so let's see. The first option for such uh, you know finding or such an exploration is Mars itself. We know that Mars surface is somewhat similar to that of Earth. We know that it is there are dust, rocks, sand, everything on the surface of Mars, just like we have on Earth. So there was this hypothesis, that Mars ocean hypothesis. So what is that called? It's this hypothesis says that 1/3 of the surface of Mars was once covered by water, though the water on Mars is no longer oceanic, which means that it is said that some ages ago, century like billions of years ago, 1/3 of the surface of Mars was covered with water. So if we consider like that, there's a good chance that life was there on Mars, but we haven't found any information or any knowledge regarding the life on Mars. Still, we are searching for that. You know that it's recently the Perseverance lander, the rover lander, etc. Those things landed on the Mars, and what one of the things it is searching will be the presence of life on Mars, right? Hope you have heard about. We talked about that in the class regarding the
Yes, ma'am.
Perseverance. So the water on Mars exists as ice. Now also we know that there is presence of water on Mars, or even our moon has water. But where is it confined? It's in the poles. It exists as ice, and much of it is residing in the ice caps in the polar regions. A small amount present in the atmosphere as vapor. So that that the Mars has a feeble atmosphere, and there are some amount of this um, water molecules present in the atmosphere, and most of these water molecules are in the ice caps of Mars in the form of ice. So why there is no liquid water on Mars? What is the reason behind it? There is two reasons why there is no um, life on the water on Mars. The first one is the atmospheric pressure. You know that a certain atmospheric pressure is needed for you know any amount of any molecule can sustain. In the case water, there is a good, we know that Earth, the condition of Earth we know, the atmosphere is giving us enough pressure for the organisms to live, with the water to exist, etc. But the pressure on Mars is really less, only 0.6 percentage of Earth's mean sea level pressure. What is this mean sea level? Anybody know? That is the height where
the water of sea is there. That is called the mean sea level. Okay, that's taken as some zero, and from zero we'll take, when we find or when we talk about the height of mountains like Everest, we tell that okay, 8 kilometers above mean sea level, which means that from the sea level, Everest stands high as some 8 kilometers. Okay, the second reason is the average temperature is far too low. Temperature is really less. The temperature is really less. What is the temperature on the surface of Mars? Maybe it's a minus 63 degrees Celsius. That is
Yes, ma'am,
also,
it's in minus.
yes, it's a minus because it is far away from sun than that of Earth, right?
Yes, ma'am.
Yes. So these are the two reasons why there is no liquid water on Mars. But in July 2018, the Italian Space Agency reported the detection of subglacial lake on Mars. Subglacial lake on Mars, some 1.5 kilometers below the southern polar ice cap, which means that it is below the glaciers, not like the pond or lake that we see on Earth, but they say that from some remote sensing method, they found that 1.5 kilometers below the surface of the polar ice cap, there is, the subglacial lake. It is 20 kilometers wide, the first evidence for a stable body of liquid water on the planet Mars. So we know that the temperature at the bottom, at that place, in the polar ice cap is estimated at minus 68 degrees Celsius. So scientists assume that it can be due to some chemical effects. The water is stayed as liquid. Maybe the effect of elements like magnesium and molecule like calcium perchlorate. Enceladus. So before studying more about Enceladus, I want to tell you about something very interesting which happens in the bottom of the seas. Can you see this thing? Some black smoke is arising from the bottom of the sea. Okay, so what you see is the seabed. Seabed is the bottom of the sea. In the bottom of the sea, sunlight is not there. It is dark almost. Okay, when you look at after some 200 or 300 meters from the surface, there is no presence of sunlight. So that's why no diverse life maybe in the bottom of the sea if it is too deep. So consider this. There is this kind of phenomena which happens in the um, bottom of the sea. It was like some 40 years ago. Okay, so we were talking about this seabed phenomenon. It's called the hydrothermal vents. So what is happening here? You know that in a volcano, what is happening? The magma, the energy from within the earth is firing from the mouth of the volcano. But consider there is a small fissure on the surface of this earth, and from that surface, slowly some amount of gas molecules or some kind of what is there inside the earth is coming up. Slowly, it's not like a volcano, but a small crack is there on the surface of earth, and from that it is coming. So this is similar to that. In the sea, but since it is too far, below, what happens, there can be some kind of these cracks or fissures. So whenever these kind of fissures are there, if there is some kind of magma present near the fissure, these things will slowly come up from that. So here you can see a black smoke coming from there, and it is from inside the earth, and it is called the hydrothermal vents. So at that area, the temperature of the seawater will be really high. Okay, but you can see some kind of living organism, some kind of tube worms and all attached to this vents. Can you see that? The white and red one.
Yes, ma'am.
Sometimes even fish can be there. Some kind of small organisms can also be there. So what does that mean? Without the presence of sunlight also, this area there is no sunlight. Without the presence of sunlight, life can be there. Isn't it a good news? It was some 40 years ago when Vikings, you know about Vikings missions to Mars, and those missions were the kind of first because the Viking mission was to find whether there is life on Mars. So we were trying to find life on Mars, and then we found some crazy thing on Earth, like hydrothermal vents. So we understood that without the presence of sunlight also, there can be life.
And
So
this video is from Mars.
no, it's from Earth only.
Okay.
It's from the seabed of Earth. There are hundreds, thousands of such hydrothermal vents all around the ocean beds. Okay.
Okay, ma'am.
Okay. So now let's have a look on Enceladus. Enceladus is a moon of Saturn, and this is Enceladus. Maybe you can see. Okay. So this is the moon of Saturn. Okay. And have you heard about this moon before? Enceladus. Hmm?
No, ma'am.
No, this moon of Saturn. Because there are many research activities now happening on this particular satellite. You know what is Higgins missions? You remember that, right? Hmm? I feel that after 2-3 weeks without class, you people got no interest in space science now.
No, ma'am.
No. So we studied about Cassidy Higgins in previous classes. Maybe you have forgotten it. Hmm. No, don't worry. We'll once again talk about Cassini Huygens mission. You remember the mission to Saturn?
Yes, ma'am.
Yes, it's the Cassini Huygens mission. Okay, so this is a satellite of Saturn, the Enceladus. It is said that throughout this planet's surface there is an ocean. Okay, so what we see is not ocean. These are actually what ice, thick layers of ice, and inside these thick layers of ice there is presence of ocean water, that is water, liquid water. Okay, so I'll tell you how scientists confirmed whether the presence of such water. Now, can you see three or four stripes here?
Yes.
Yes, these are called the trigger stripes. Okay, so these are fissures in this what to say, ice shell. I told you, you please look at this figure. This is a vertical section of Enceladus. There is a thick ice shell, and inside thick ice shell there is ocean. It is possible, in some cold countries, the rivers freeze. Okay, when rivers freeze, what happens? The ice, which is having a less density than that of water, what will happen? It will
Right.
sink or float. What will happen?
Float.
It will float.
Float.
So when ice is, there, if we put one ice cube into water, it will float, right?
So similarly, in cold countries, whenever the temperature is below 0 degrees Celsius, water will freeze. So since the density of ice is less than that of water, the ice will float. So it will act as a temperature, what to say, what to say, a thermal wear. Okay, which means that it won't allow the outer low temperature to get into this water body. So that's how the whole river won't get frozen. There is a layer of ice formation on the surface of the these water bodies, and the fish, then the organisms inside the water will be safe. You know that in cold countries this always happens. So in Enceladus there is a thick layer of ice, and after the thick layer of ice there is ocean. So you see this video, please have a look at it. Okay, so when Cassini, the spacecraft which was sent to study more about the Saturn and the rings, etc., it found something, which means that it found some kind of thing was sprouting out from the Enceladus. Okay, you see this kind of sproutings, can you see? Hmm?
Yes, ma'am.
Yes, so these sprouting,
Yes, ma'am.
it's called the Jays. Shivam, you joined, right?
Yes.
Oh, very good, very good. So we were talking about the oceans and life forms beyond Earth. Okay, we haven't found any life form beyond Earth, but we have found water beyond Earth. So if there is water, there is a good possibility of life. So that's what we were talking about. So you know this tiger stripes, this geysers kind of sproutings are coming from these fissures. So from where
From
this
what,
sprout?
ma'am?
Sorry.
From what?
From these fissures, these stripes, these are actually cracks in this uh, big ice shell.
Okay.
Okay. So whenever inside pressure is high, this some amount of water is sprouting out from this stripes, the tiger stripes of Enceladus. It was Cassini spacecraft which confirmed this kind of geysers of waters in 2005, and in 2008 it analyzed these sproutings more deeply. Okay, so you know that in the previous picture we talked about hydrothermal vents. So whenever there is fissure on the seabed, this kind of things can come. So it is due to the hydrothermal vents. Can you see this picture? This one. See in the seabed of or Enceladus, this kind of hydrothermal vent activities are happening. So due to that, high amount of hydrogen is also there in the sproutings. Okay. So this is how we came to know that there is a big ocean beyond it, beyond this ice shell.
So the video, that is the gas type of thing that's coming out.
Yes, it is actually not gas. There
It is
is
a solid.
gas. Sorry,
It should be solid.
not solid, maybe some kind of fluid, because it is changing its shapes abruptly, right?
Ma'am, I meant something. I mean, solid particles like a
So,
cloud.
oh, maybe there is good chance of that. Maybe along with ice, it is coming up, right?
Yes, with the
Hmm.
small particles of ice.
Yes. So particles of ice, when they are in, warm above certain temperature, we can call it water. Actually, it was geysers of water which were sprouting out from these fissures. Okay. So the melting of ocean water and the geysers appear to be driven by tidal flux from the Saturn. So don't worry regarding that. I'll tell you. You know that due to the sun
and moon, we have tides, right? We do have tides. So similarly, consider the tides which are affecting on Enceladus due to Saturn. If we are getting such a huge tide, when we consider regarding the effect is more from moon on Earth, consider the kind of tides by tidal forcing by Saturn. It's going to be very huge, right? Hmm?
Yes, ma'am.
Yes. So it is due to these tides that the surface, these rocky cores and all continuously, crushed and dilated. Hmm? When it is revolving around the Saturn, that can be one of the reason why these hydrothermal vents are there. Am I clear? Everyone is clear regarding the hydrothermal vents, right?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. Okay. So the next planet, next candidate or is Europa. So now you remember this picture. This picture. Anywhere have you seen this picture or a part of it?
Ma'am, in the
Ma'am, in the
first
first
slide.
you showed
Yes, in the first slide we showed. So which was this? It was
Europa.
Europa. Okay. So Europa is a satellite of which planet?
Jupiter.
Jupiter. Very good. So Europa is one of the giant satellite of Jupiter, along with the other three. Which are they?
Io,
Hmm.
Ganymede,
Hmm.
Callisto,
Very good. Io, Ganymede, Callisto, Europa. Very good. So who was the first one to find all these satellites?
Galileo Galilei.
Okay. A layer of liquid water exists beneath Europa's surface. Similar to that of Enceladus. Enceladus is a moon of which planet?
Saturn.
Very good, Saturn. So Europa, the moon of Jupiter,
Yes.
similar to that of Jupiter, this Europa is also said to have a you know layer of liquid water beneath this icy surface. Again, why there is liquid water? What is the reason? Hmm? The reason can be again the tidal forcing due to Jupiter. See, Jupiter, Saturn, although these bodies are really huge, if they can, due to the difference in the gravitational effect in different sides of the or different parts of the satellite, the tidal effect can be really intense. You know how this tides affect, I'm sorry. So consider Earth. What is Earth? Let me. So consider this is Earth, okay, and there is Moon. So, so Moon is both this Earth and Moon are attracting each other. That you already know, right? Hmm?
So, ma'am, the tidal force.
Yeah.
Ma'am, the tidal force of the moon will from the tidal force of Earth is their heat. Is the heat generated on moon or the shape is changed like a little bit?
Are you asking that the tidal, force by on Earth is same to that of the tidal force on Moon? Is it? I think the question you asking is this: if the gravitational force on Earth due to Moon and the force on Moon due to Earth is same, the tidal force is also same. Is it what you are asking? I think it is. If it is so, I'll
Ma'am,
tell you, it is due to the fluid presence. That is the presence of water on Earth, which make it tidally, active.
ma'am,
Yes.
I was asking, is there any amount of heat generated on moon due to Earth's gravity?
Earth gravity. I think no, because there is no any geographical or geological activity which is happening on the moon. So if that is that is the thing, what happens is due to the gravitational force of Earth, no kind this kind of heat can be generated. If there was some kind of fluid or any kind of gravitational activity which is happening on the moon, then we could have said that okay, due to the gravitational energy of Earth, this moon can have some kind of the presence of heat inside it. I haven't checked out any journals regarding that. Maybe logically I feel so. Maybe I'll read more about it and we'll discuss in the next class. But I think this is a scenario. Like if it is due to tides, then if only fluid presence is there, presence of fluid or water, especially water, then only this can happen. Okay.
Okay, ma'am.
So Shivam, is it okay?
Yes.
Okay. So whenever the okay, now when moon is here, so the moon's attraction is more here, right? Because it is closer here. This part of Earth is close, and this part is really far, right? So this here water will be having more attraction towards the moon, while here less attraction. So what will happen? Just like a very very feeble way, like spaghettification happens near when we go to black hole. There is gradient in gravitational force. Anyway, maybe I'll show you some video regarding the tidal force in the coming session. Today I don't know whether if there is time, I'll show you today. Okay, so here the water level will be high due to the presence of moon nearby. The moon will exert more gravitational force here, but here it is less. How? If water levels has to be higher here, it has to get from the other part of the earth, right?
Ma'am, but
Hmm.
the diameter of Earth is is very small as compared to the distance of Earth and Moon. So
But still,
force would be approximately same.
no. Approximately, it's not same. If even though you consider the distance between Earth and Moon, then also we consider Earth itself. Okay, Earth has a particular diameter, and nearby the Moon, wherever the Moon is there, the force is of course, even though slightly, it is more than that of the other part. So water will, or of course, will rise up. That's how the tides are there. Let me see whether I'll get some any video regarding that. Okay, about any small video regarding then you will understand it clearly. Okay, I've got one. Let me share some. Okay, I
But
can.
what
I
force
hope
could
you can
move
see.
such a massive body of water?
See, Did you see how this water? See, now the water level is here, okay? So it is rise up to this much. See how intense is the tidal force up to this much, and then during low tide it is less. So how is this force produced? It's gravity. Consider this is Earth, and this blue thing is the ocean. Okay, consider the blue is the ocean. I hope you can see the screen, right?
Yes, ma'am.
Okay, and here there is moon, and what will happen? Hmm? This here, this portion of Earth is attracted to the moon than this part. So what will happen? See, water will move, of course. This. Did you see it? Can you see this?
Yes, ma'am.
Okay, so there is height difference. And here we talk about high tide. And opposite side is low tide. Mm, yeah. When Earth and Moon is moving, so this will happen. Please pay attention. See,
Is high tide is about the moon because this.
okay.
Or-
So I hope you understand regard. See, if Moon is affecting the fluid motion on Earth, such a large body, consider the tidal effect that can be done by big planets like Saturn and Jupiter on their small satellites. Okay, let's go back to our PowerPoint. Oh no, not this one. So yes, we were on Europa's slide, right? So heat from tidal flexing allows the subsurface ocean to remain liquid. So it will provide definite temperature. It's because it's fluid there, it will get the definite temperatures. Okay, due to friction, like continuous, this kind of motion is there due to tides. So there is friction there, and that's why it will get a warmth. The water will get enough warmth to stay in liquid stage. Shivam, did you understand that?
Yes, ma'am.
Okay, very good. Is there any doubt? Is there any doubt? Okay, I hope there is no. So it is estimated that the outer crust of solid ice is approximately 10 to 30 kilometers thick, including a ductile warm ice layer. Okay, so there is a warm ice layer here, and the icy crust sea, and there is subsurface ocean, and after that there is volcanic seafloor. If the seafloor is volcanic, what will happen? This thing will happen. Hydrothermal vents. So it is possible without sunlight. Here there can be life. We are not sure yet. To find whether there is life or not, we have to send probes to on landers to those planets. Unless we go there, we can't find any life there. We don't expect some intelligent life there, but some kind of microorganisms that we are expecting. But the volume of Europa's ocean is more than 2 times the volume of Earth's ocean, which means that on the surface of Europa, 2 times more water is there than that of Earth. Okay. So similarly, the Ganymede also this kind of
hypothesis is there where subsurface saline ocean is theorized to exist on Ganymede, again the moon of Jupiter, following observation by the Hubble Space Telescope in 2015. Did you read that, last few days ago, the Hubble Space Telescope had some problems and it stopped clicking pictures? Did you read regarding that?
No, ma'am.
Okay, there was this some problem, technical problem with the I think not with the telescope, but with the ground station. I don't know whether they have cleared it or not. And after that, I didn't hear anything about that. Yes, anyway, the patterns in auroral belts and rocking of the magnetic field suggest the presence of an ocean beneath the surface of Ganymede. Okay, so consider the structure of Ganymede here. So here you can see the ice layers, then different ice layers, right? And in between that, there are different liquid ocean layers. As depth is increasing, the salinity, that is the presence of salt content, also increases. So which is the largest satellite on solar system?
Ganymede.
Yes, it is bigger than Mercury, right? So it is estimated to be 100 kilometers deep within the surface lying below a crust of 150 kilometers of ice. So again, there are some candidates like Ceres. So what is Ceres?
Dwarf planet.
It is a dwarf planet. And where is it located?
What, ma'am?
Where is it located?
Asteroid belt.
Yes, it is located in the asteroid belt. So it is located in the asteroid belt. Like almost 1/4 of the asteroid belt mass is within the Ceres. Okay, so that huge is Ceres. So when we pass by asteroid belt to reach the outer planets, then we sometimes we find certain things. Just like we wasn't expecting any kind of geysers on Enceladus surface, but when Saturn the Cassini mission was observing Saturn and its satellites, it accidentally got informed that what find out that there is presence of water sproutings in Enceladus. So similarly, it was during a flyby mission, something special about Ceres also found. Let's see what was that. Ceres appears to be differentiated into a rocky core and an icy mantle. A remnant internal ocean of the Ceres appears to be differentiated into a rocky core and icy mantle. Okay, mantle and all are different layers on the interior of any planet. Our Earth has a core, outer core, mantle, and crust. Okay, so broadly we can call core, mantle, and crust. So mantle is a layer between the core and the crust. So similarly, it is said that the Ceres, the dwarf planet, has icy mantle, and there is internal ocean of liquid water under the layer of ice. The surface is probably a mixture of water ice and various hydrated minerals such as carbonates and clay. Anyway, just don't worry about different scientific terms. If you have any doubt, just ask me. Just nothing important regarding that for you people. So in 2014, emissions of water vapor was detected from several regions of Ceres. So it was in 2014, different water vapor was detected. Like the presence of water vapor was detected from the vicinity of Ceres. So if water vapor was, coming from Ceres, which indicates that there could have been a more amount of water vapor or water present in the surface, right? Not at least not in the surface, but in the mantle. So that was unexpected because large bodies in the asteroid belt do not typically emit vapor. It is the comets, which emits vapor. You know, the big tails, two tails of comet. And it is why there is comets, tails for the comets. Hmm? There are two tails, right? The dust tail and iron tail. Hmm? And this kind of water vapor emission is the hallmark of comets, not of that of any body in the asteroid belt. But Sirius was showing that. So we expect that the surface, or at least in the layers beneath the surface, there can be water ice. Sirius also features a mountain called Ahuna Mons that is thought to be cryovolcanic dome that facilitates movement of cryovolcanic magma. That is a cool thing. Instead of hot things, cool things can be emitted from a volcano. Okay.
Okay,
Such
ma'am.
volcanoes are present in Sirius. And even yes.
You said volcanoes are present, so the hydrothermal vent will be there.
Hydrothermal vents can be there, or there can be possible if there is liquid ocean there, and whenever this liquid this the gases beneath earth is coming and interacting with the water, the sea water at the seabed, then there is a good possibility of chemical energy production there, so that there can be life.
Okay, ma'am.
But in Sirius, we're not sure about liquid water. It says that there is icy mantle and there is mixture of water, ice, and various minerals. Okay,
Okay, ma'am.
not directly liquid water. But if there is liquid water and this volcanic activities, then we can know that we can assess that there is a good possibility of hydrothermal vents there. Okay.
Yes, ma'am. Thank you.
Yes, very good. So even the ice giants, Uranus and Neptune, and also said to have supercritical water ocean beneath their clouds. There is a good possibility of uh, water ocean beneath their clouds, and it accounts for about 2/3 of their total mass, most likely surrounding small rocky cores. In 2006 study by Vikrovitz and Ingersoll ruled out the possibility of such water ocean existing in Neptune. These are just hypotheses that we are not sure about it, but still there is a good possibility of presence. We do not have any proof to provide like we have for Enceladus. So this kind of planet is thought to be common in extrasolar planetary system. So in the case of Pluto, also such possibility is there. That is in June 2020. Last year, astronomers reported evidence that the dwarf planet Pluto may have had a subsurface ocean and consequently may have been habitable when it was first formed. So similarly, here in the case of Pluto and all, there is a good chance that if there was subsurface ocean, and there is no way that any such any sunlight can be penetrate to that distance. Very feeble amount of light, which is not optimum for life formation or photosynthesis or whatever such things. So it can be hydrothermal vents which powers life forms if there is such an ocean and a volcanic or maybe say an active geological conditions. So yes, these are just starts.
There are many things we need to study about oceans beyond Earth, because the Kepler planet and all. There are different planets. There are a lot of planets beyond our solar system, right? Planets which are revolving around other stars. And if such conditions persist, there can be oceans. And if oceans are there, there's a good chance that there can be life. So now at this point, all we can do is hypothesize and find for proofs, send probes, send landers to different planets, satellites, etc., to find more truth, more evidence regarding oceans and life beyond Earth. Okay. Any doubt
Okay,
is
ma'am.
there?
No, ma'am.
No, ma'am.
Okay.